weatherized up here, but at least it's nice enough nobody got wet walking over from the field house. The good news is this is about as far as you can go. We couldn't make you walk any further. Okay, so I'm Dr. Beth Carl. I'm the department chair in the Department of Mechanical and Mechatronics Engineering Technology. We got a couple folks trying to find some more chairs. Did not be quite succeeding as much as we thought on that one. So I want to talk to you about mechanical engineering technology, mechatronics engineering technology, and robotics and manufacturing engineering technology. Y'all are in the first part of the college luncheon, so the question becomes, why should you come to RIT? And specifically, now that you're at RIT, why should you study engineering technology? So pretty much some of the questions going through some of your minds. You know, they said, why should I go to this school versus that one? It looks like the cameras has managed to find a few more chairs. Said a few, I didn't say a ton. So, what are some of the advantages that RIT offers? One of the big ones is our co-op program. Everybody in education. What this translates to is, okay, you're studying, go be what you're studying. These are paid, we'll talk more about it down the road, but this is a huge part of being at RIT, are these cooperative education programs where you get to literally start doing whatever career you're studying for while you're still in school. We also have a combined accelerated bachelor's master's. So if you've got the academic strength and you're interested, you can get a master's program in the same amount of time. And we'll talk a little bit more about that. And then if you start looking at facilities, we'll have some of those labs open later for sort of a self-tour. That's what the QR code on the tables is, and there's brief descriptions of the labs, and I'll tell you the last slide which of those labs are open today with either students or faculty that can talk about those. And then the next question is, why engineering technology? Okay, so engineering technology is very applied, very focused on doing engineering. We're not going to spend all of our time deriving the theories. We're going to talk about how do we use those theories to solve problems in industry. So along with that is almost every course is going to have some experiential component. It may be an explicit lab course. It may be a design project. One thing we're going to do is get you, your first year, learning how to go and manufacture things, whether it's 3D printers, CNCs, machine tools, not because I want to turn any of you into people that are going to be making. Your goal would be to be more of the engineer, but one, if you have a clue how to make it, make sure they're an engineer. And that way, when I send you to go build a dynamometer, characterize your engine, which is what I'm going to do to my students here, Coach Thursday. I know that when they go down to the machine tools lab, they will come back, and the only difference in their hands, they will be dirtier. Okay, I want you safe. So that's a lot of why we have the experiential components. It makes you a better engineer. It gives you an opportunity to see how what you're learning in class fits into something practical right away. Good pay for these jobs. For the bachelor's level, somewhere in the 70s to 80s range. Yeah, there are some that exceed that. Last year, I think I had somebody at 130, but they were living in Silicon Valley, so it wasn't going to get them as much. And then if you've done the bachelor's, master's, that's going to throw another 10 to 15K on top of that. And our placement rate is darn near 100%. Placement means grad school, industry, military, so something in your field. And another thing that sets engineering technology apart from more traditional engineering is we all come with industry experience. I worked in the medical health device industry before I came. Superconducting magnets for MRIs primarily, and then I continued consulting once I got here. So that's what we bring, is practical real world education, taught by people that have actually been engineers, not just academics. We also have a lot of diversity of experiences in our programs. Everybody in industry has proven that the more varied viewpoints you can bring in, the better your company will be, the better your products. And I mean that diversity in rural versus city versus suburbs, varying economic situations, varying access to courses. A lot of folks coming from smaller districts, often rural, don't have opportunities to take calculus. Okay? We'll get you there. So, I want the diversity in every possible way. And along with that becomes a lot of opportunities to then grow. When I get into teams and projects, the broader the variety, and that's going to start crossing by even your second year, well, actually even your first year, crossing across disciplines. Because the mechanical engineers are going to think in one way and have one set of focus. The robotics are going to be thinking in a somewhat different way. That diversity of thought. Accelerated bachelor's, master's. Okay. Our bachelor's programs are 5 years. Okay, now moms and dads are going, I'm going to pay tuition for 5 years. Couple moms and dads groaning on that one? No, you don't. For your bachelor's, you pay 8 semesters. Folks are off on co-op working. You don't pay while you're on co-op. If you do the combined accelerated bachelor's master's, you're now going to do 10 semesters in there. So that's going to give you, instead of going out as, say, an engineer 1, you'd get an engineer 2 title. Okay? Along with that, more responsibility because you have more experience. And you would start your graduate work in your 3rd year. And this is something that you can check off on your application. Yes, I'm interested in that. And if your high school grades are good enough, yeah, you can go into that. It's conditional. We're going to review you along the way and make sure that you have the academic strength to do graduate work, because the requirements for graduate classes are higher, and the required GPA to graduate is also higher. Okay, you learned about the VSMS, you didn't check it off. There's still routes to get and do that at the end of your 2nd year, so it's an option for anybody. So, comments from a current student, and this is where we're going to have a panel of students coming and talking when I get done. So we have a lot of resources. On the academic side, we very much want to see you succeed. So all the faculty have office hours. We have tutors, learning assistants in here, advisors, and we've got a few different levels of advisors. There's the academic advisors who we sort of joke on day 1 are your new best friends. You're going to make a lot of contact them, making sure you're getting into courses, staying on track, because we want you graduating on time. There's a lot of courses in an engineering or engineering technology program that follow. You have to do this before you can do this, before you can do this, before you can do this. And if you decide I don't want to take statics till my 4th year, you're not going to get very far. So the advisor is going to help keep you on track. We have math study centers, writing centers. So there's a lot of support for your academics. And then we also have a lot of support beyond academics. So we've got an embedded counselor in the college who's actually down in our main floor. So there's a lot of other supports for you. What are you going to do beyond the classroom? A lot of students are getting involved in doing some research. We've got faculty doing biomechatronics, looking at wearables. We've got faculty looking at pulmonary systems, electrical vehicles, robotics, AI. So there's a variety of research opportunities. Also a lot of study abroad opportunities. One of my colleagues is leading a study abroad looking at the auto industry in Germany. Would be the upper picture there. I had the pleasure of doing that. I guess at this point, it's 4 years ago. It's a fabulous experience, and that's not the only study abroad. Clubs. There's over 300 clubs on campus, and if there isn't a club you're interested in, start one. Okay. A couple years ago, we had a group that revised the American Welding Society, and we started a Society of Plastic Engineers within our department. There was a group a few years ago that decided they wanted a Nerf gun club. It's a very popular club, I might add. And there's entrepreneurship opportunities. There's a variety of students that I'm familiar with that have gone out with provisional patents and are starting their companies. One just last year won $500,000 towards his development looking at the system for cleaning udders for cows. If you didn't, you probably walked by the shed. Actually, there's no way to get from there to here without walking by the shed. We've got a lot of maker facilities in there. A lot of focusing on student-oriented, not faculty. And as I said, the majority of our classes have some form of lab component. So what about us? What are you going to have as careers coming out of programs in this department? So we've got a couple of students here, alumni highlighted, somebody at Tesla, and Google. These are common places. We have a lot of students that have gone to Tesla. And part of it is our co-op program. So co-op is starting in your third year. You will have semesters where you are not on campus, unless your co-op's on campus. You are out working in industry as junior engineers. You're paid to do this, and a lot of students get job offers at their co-op companies. You are expected on these companies to be behaving as newbie engineers. No, you don't have a lot of experience, but you've been learning something. How will this fit? Probably doing some levels of design, testing, seeing what's going down on the manufacturing floor, because you can make the best design you think, but until somebody can make it, it's actually relatively ugly artwork. If you've ever done engineering drawings, they're boring. Most people don't want to put them on their walls, but what you can make from them is really cool. So you would start this in your third year, and this is why we're a 5-year program. Because you will have had 4 semesters, that's 2 summers, and then a fall and a spring, separated out to go and actually be an engineer. So let's talk a bit about the majors themselves. Okay, so we've got three. We've got mechanical, mechatronics, and robotics and manufacturing. Everybody's got a common foundation, and in the first couple of years, most of your classes are going to be common. You have calculus, you have physics, you have chemistry, right? And you've got your general education courses. That's common. Everybody's going to get some mechanics, some materials, some fluid power, some electrical, some CAD, computer-aided drafting, some manufacturing skills. And then we start breaking it down. Mechanicals. We're going to be focused more on design. So now you need a lot more depth in dynamics, strength materials, plastics, thermodynamics, fluid mechanics, sensors, computational skills, machine design. So very focused on more of a mechanical or thermal design. Mechatronics, controlling and making things move. Mechatronics is where you're going to take the mechanical, the electrical, throw in some sensors and computers. You're really the integrators. So we're going to pick up a lot more on the electronics, mechanical motion, system design, automation, controls, robotics. So how do we make things move? And then the robotics and manufacturing. Our focus is a lot more on the robotics and automation in production. So we still have all the automation, the robotics. How do we design for manufacturing and assembly? A lot more on manufacturing systems, electronics manufacturing. The line the same as Apple has of how do you make these iPhones, the circuit boards on them. We just don't happen to make 500,000 a day. We're a lot smaller scale. And we're using it as a teaching facility and a research facility. So where do we go with this? Mechanical engineering, we also have within this options of robotics and automation and product design. So for the next 3 slides, we're going to look at employers and job titles. And everybody always says, can I do automotive and can I do aerospace? Absolutely. Boeing, General Dynamics, General Motors, Lockheed, Tesla. But we're also a lot broader than just auto and aero. You'll see some things in here. Morton Salt, Fisher Price. We're getting into a lot of consumer products. Roebuck Brewing. There's an amazing amount of engineering that goes into any of the food companies, food and beverage, and job titles. First of all, I want you to notice that the degree program is engineering technology. Do you see a single technician, technologist job title? No. You're engineers. You can get certified as a professional engineer. Your degree is ABET accredited. It's just a very applied route. You don't spend time deriving equations, we spend time using equations. Moving on to the mechatronics, you're going to start seeing there's a lot of overlap in these companies because there's a lot of different things you can do with them. But you do start picking up Boston Scientific. I don't know if any of you have ever seen some of the Boston Scientific commercials. They have robots doing all sorts of fun things. They've got robot dogs, they've got robots doing parkour. Check them out. And that's one of the places that we've sent our mechatronics students as moms. And you start picking up more on the controls, more on the electrical. Robotics and manufacturing, More aerospace, Honda. Start picking up a bit more on some of the manufacturing process quality side. Similar companies across them, similar titles, a lot of ability to specialize, but yet move around. So look, we talked about mechanical manufacturing, engineering technology, and mechatronics. RIT also has electrical and computer engineering technology. So on the left, mechanical and robotics, so structure and motion, mechanics, building physical things. On the far right, we've got electrical and computer. So now a lot of the computers, the controls, and our mechatronics program sits in the middle. It's got the mechanical, it's got the electrical and computer. The mechatronics, you're the integrators. Okay, so a couple of websites here, one for the college, one for some students. We're going to do a panel in just a couple seconds. And what's coming up, we have some of the labs that are open that are highlighted on the tables, and we'll have some people pointing in different directions. And then we were asked to be done by 11:15 so that you all can get lunch, admissions, dorm tours. If you're doing ROTC, disabilities, all of those. So I'm going to ask my panel to come up. Where did my panelists go? Panelists. Very good. Here's my panelists. So I will let the panelists introduce themselves. I can answer questions, but I'm also very well aware that a lot of times the students are actually the ones that are better able to answer your questions. So I'm going to let the panelists introduce themselves.